Okay, so you should be using this video in order to help you practice or warm up understanding and remembering how to name ionic and covalent bonds. Okay, so now that we're trying to mash up the two, it's important that you remember all the rules. So back to a long time ago, we talked about I'm on C and N. And here the I in ionic means that you're bonded to a metal and a nonmetal, and covalent means you're bonded to a nonmetal and a nonmetal. Okay, so let's go on to this practice over here. Okay, when we're going from a name to a formula, it's usually very easy to determine whether it's an ionic or covalent compound. Okay, just by looking at its name. There's usually two ways to determine whether something is ionic or covalent, and they have different rules in writing the formula. So for instance, gallium arsenide. Here, we can automatically tell it's ionic. Why? Because it has no prefixes. No prefixes means it's ionic. We also can double check by checking gallium. Gallium is over here. That's a metal. Arsenic is here, which is a nonmetal, which tells us that it's an ionic compound. Now, when we're going from a name to a formula in an ionic compound, we have to think about charges. So gallium has a +3 charge, so I'm going to write +3 here. And arsenide or arsenic has a -3 charge, so I'm going to write -3 here. Ionic bonds are all about canceling out charges, right? So remember, ionic have ions, which are cations and anions that you're always trying to make neutral. So if you have 3 pluses and 3 minuses, how many of each do you need to cancel out the charges? Well, we only need 1 of each. So we write it like that, 1 of each. Next, we have gold 3 sulfate. Now, we automatically know that this is ionic because there's actually 3 ways here. 1, there's no prefixes, so it's ionic. When there's a Roman numeral, we automatically know it's ionic. And we can also check next door here, gold is a metal, which makes that ionic as well. When you have a Roman numeral, remember that Roman numerals are always positive. That is a Roman numeral for 3. Look at the ending here. Sulfate, okay, doesn't have an IDE ending. That means there must be a polyatomic involved. Where do you see sulfate? Right here. Sulfate has a -2 charge, so I'm going to make a note here that it's -2. If we want to cancel out the charges, how many of each do I need so that it becomes a neutral compound? Well, I can add another +3, another -2, so I have 6 and 4. So if I add another -2, it now becomes 6 and 6, cancels out. So how do I properly write that? I need how many golds? I need 2. Sulfate is a polyatomic, so I need parentheses, and I need 3 of them. So that's how we write gold 3 sulfate. Next, you have heptanitrogen monosulfides. Here we have prefixes, so we automatically know that this is a covalent compound. Just to double check, you can look up nitrogen and sulfur. Those are your 2 nonmetals, so we know that this is a covalent compound. The prefixes tell us how many of that element we have. Hepta is 7, nana is 9. So, nitrogen is the letter N. We have 7 nitrogens. Sulfide is sulfur, and we have 9 of those. Okay, next, dinitrogen tetraphosphide. Here we have di and tetra, so we automatically know this is covalent. If you want to double check, nitrogen and phosphorus are right on top of each other. Those are both nonmetals. Okay, our prefixes say that di is 2 and tetra is 4. So if you don't remember these prefixes, I would suggest looking back at your notes and looking up your prefixes. So, nitrogen is the letter N. There's 2 of those. Phosphide is phosphorus. And we have 4 of those. Tetra, always think tetras. Here we have chromium 2 oxide. We have a Roman numeral, so we know automatically it's ionic. Chromium is here. That's a metal. It's definitely ionic. The Roman numeral tells us that it's a positive, and that is a 2. This has an IDE ending, so we know it's the element oxygen. Oxygen is here. It has a -2 charge. So I'm going to write -2. How many of each do I need to cancel out the charges? Just 1 of each, because 2 cancels out 2. So this becomes 1 chromium and 1 oxygen. Now we're going to go backwards from formula to name. So here we also need to do the same thing. Identify if it's ionic or covalent because they have different rules. So let's look up C and O. Carbon is over here and oxygen is also over here, making it 2 nonmetals. This is a covalent compound. Now remember your rules for covalent compounds. First element keeps its name, second element gets an IDE ending, and we use prefixes. Okay? The other rule that you need to consider is that mono is only used in the second element. Okay? So here, carbon keeps its name, but we have only 1 of them. But we don't use mono because it's only reserved for the second element. So all we do is write carbon. Now, how many oxygens do we have? 1. So the prefix we must use is mono, but it also needs to have an IDE ending. So this becomes monoxide. Perfect. All right, next we have KNO2. Potassium is over here, which means it has a metal, which automatically tells us that this is an ionic compound. Now remember, with ionic compounds, it's important to count whether you have only 2 elements or if you have 3. So let's count how many capital letters we have here. We have 3 capital letters. What does that mean for us? According to the rules here, that means a polyatomic is in that formula. So metal keeps its name, and we got to look up the name of the polyatomic and write it exactly the way it is. So here, K is potassium. So I'm going to write potassium. Now NO2 is a polyatomic because we have 3 or more elements. So I'm going to look at my list here. Where is NO2? It's right here. Its name is nitrite. Be careful between nitrate and nitrite and write it properly. This is nitrite. Okay, next, P4O10. Look at your periodic table. P and O are both nonmetals, so this is a covalent compound. Remember, we got to use prefixes. What is a prefix for 4? Think of the game, Tetris. So this is tetra, and it keeps its name phosphorus. Then 10 is deca. That oxygen must end in an IDE, so this becomes decoxide. Okay, next, it's a BaPO4. Ba is found right here. That is a metal, making this ionic. If it's ionic, you must count. We have 3 capital letters. That means that there is a polyatomic. We're going to name the metal. Ba was once again barium, so I'm going to write barium. now it's time to look for this polyatomic, so look at your list. Where is PO4? It's right here. The name is phosphate. So we're going to write it exactly the way it's spelled. Phosphate. Perfect. Next is MgCl2. So we look over here. This is magnesium. That is a metal. So we know that this is ionic. Now, this has how many capital letters? Only 2. So let's recap. What do we do with only 2 elements? With 2 elements, you keep the name of its metal, and then you change the non-metal to IDE. So, Mg is magnesium. Cl is chlorine, but we change it to IDE, so now it becomes chloride. All right, so I hope that this was useful to you, and good luck on your studying for the quiz or the test that is coming up for you guys.